welcome to all present here today for the ChangeMaker20 Summit, where visionaries and change agents unite to catalyze global transformation. Through collaboration and innovation, we embark on a journey to address challenges, inspire action, and forge a path to a brighter tomorrow. Together, we shape the future we aspire to see. Distinguished guests and esteemed participants, I am Anupa Thakur, and with great pleasure, I introduce you to our esteemed speaker, Dr. Leena Johny, Associate Fellow, Sustainable Agriculture Division at the Energy and Resource Institute, TERI. She is a PhD graduate in Life and Environmental Sciences from Deakin University, Australia. With over 12 years of experience, she specializes in plant microbe interactions, focusing on mycorrhizal biotechnology, biofertilizers, and plant secondary metabolites. Dr. Johny's work explores mycorrhiza, host preferences, secondary metabolite elicitation, and microbiome identification, aligning with agricultural and environmental sustainability goals. She pioneers the development of microbial consortia to enhance crop productivity sustainability, reducing the chemical inputs and supporting soil carbon sequestration. With 8 research papers and supervisory roles for the PhD students, she also spearheads commercial mycorrhizal production at the Center for Mycorrhiza Culture Connection. Over to you, Ms. Lee.
Thank you, Anupama. Hello, everyone. I am Dr. Leena Johny. I work with the Energy and Resources Institute, TERI, in the Sustainable Agriculture Division. As Anupama just mentioned in my bio, a very sweet bio. Thank you, Anupama. So I have my research experience basically in the field of mycorrhizal biofertilizers. And I thank the CH20 Summit and the organizers to inviting me and giving me this platform so as to share with the audience the biofertilizer segment and its contribution towards sustainable agriculture. Yes, to start with the topic, the present topic that we would be discussing today is how biofertilizers contribute to sustainable agriculture. And here we would be discussing on the challenges that the present and the successive generations would be facing and what measures should we adopt so as to achieve the sustainable agriculture goals. Next slide, please. Now, first, moving forward, the main challenge that the present scenario or the generation, the present generation is seeing is food security. Now, when we talk about food security, it is the presence of food to the present generation and to the successive generation in the safe and nutritious form. Now, the main factor here is whether food supply would be available in sufficient quantity to the people at all times. Next is whether the food that is available will be distributed by using adequate resources to the people who need in different nutritional values. Then whether the food that is being made available is safe and has all the nutrition contents based on the different requirement as per the people health. So these 3 pillars of food security, that is the presence of food, the accessibility of food, and the nutritional requirements of food are taken into consideration when we talk about food security. So here, the challenge of food security is something that we all need to address so that the problems that the present generation is facing with respect to the decrease of soil land, agricultural land, the areas which are fertile, the problems of different infestation and decrease in soil fertility. So all these factors would indirectly be affecting food security. So food security here is assurance of permanent and durable access to food. So now let's understand how we can attain food security and what are the factors which affect food security. Next slide, please. Now, soil is directly related to food security. As rightly said by Confucius, how much ever man makes accomplishment, he is actually dependent on that 6 inch of topsoil where all the agriculture produce happens. and of course the irrigation, which is from the rain. So these are the two factors which are important and are related to food security. Now, the Food and Agriculture Organization of the United States, it has projected that in the year 2015, the population is expected to rise beyond 9 billion. So, to feed the people, to feed this increasing population, chemical fertilizers is used, and it is feeding people also. So, there is increase in productivity. All this is ongoing, but there is lot of excessive use of these chemical fertilizers, inappropriate use of these chemical fertilizers, which has resulted in various environmental issues. Now the problem is, when a farmer puts chemical fertilizers to the plant, there is only 30 to 40% absorption of these nutrients, and the rest is present in the soil itself. For example, if I take an example of nitrogen fertilizer. So nitrogenous fertilizers, when put in the soil, it is only 10 to 40% of utilization by the plant. Rest 60% remains in the soil. Similarly for phosphorus, it is only 18 to 20% of phosphorus that the plant is absorbing. So just imagine, rest 80% is just lying in the soil. So this causes soil pollution. Also, these fertilizers, these chemical synthetic fertilizers gets leached, and they also go to the groundwater, causing the groundwater contamination. Next slide, please. So the chemical fertilizer agreed that it increases crop productivity, but because of this overdosage, there is lot of problems, environmental issues, whether it's soil pollution, whether it's water pollution, destruction of microbial communities, decrease in soil fertility, and the crop being more susceptible to different kinds of diseases. So there are many issues which need of the hour is to encounter these issues. Now, how we'll encounter these issues is to develop agriculture practices which promote sustainability, agriculture practices which are eco-friendly, which are socially sensitive, and have a continuous form of production which is ecologically sustainable. Next slide, please. Now, to attain this sustainability, there are some climate smart agriculture goals. And these goals are dependent on three main factors. These goals are important for increasing productivity. Now, this increasing productivity in a climate smart agriculture would mean to have efficient farming practices which have least environmental impact. Then there would be measures which would enhance the resilience of crops to different climatic changes, so that there is a continuous source of food security to the upcoming generations. So that is the second goal of climate smart agriculture. Coming on to the adopting agriculture practices where, if it is a microbial consortia, or if it is an organic farming, or it are different livelihood approaches which can be taken care of, which can lessen the greenhouse gas emissions. So these reduction of emission and the technologies and the advancement that can be taken forward in climate smart agriculture will help us to attain the sustainability goals. Next slide, please. So what is sustainability? Sustainability is the practices that would help in improving soil health, that would help in including plant health, that will maintain the soil fertility, that will preserve the environment, that would increase agriculture's productivity. It will create responsibility to be environmentally responsible. It would increase the farmer's income, and it will meet the requirements of food and fiber to the human being. Next slide, please. So sustainable agriculture, so there are a lot of practices which are adopted, which we call as organic farming in sustainable agriculture. So this can be from using manures to crop rotation to different biological management practices, or by using earthworms in vermicompost sort of organic farming. One of the important sectors of this organic farming is the utilization of biofertilizers. And biofertilizers is a very important component of sustainable agriculture. Next slide, please. Now, before understanding what is a biofertilizer, it is very important we understand what is this rhizosphere. Plant, the root area where the plant roots are there, that is called as rhizosphere. Now, the soil is a dynamic arena. It has many kinds of microorganisms, and these microorganisms are present as bulk soil microbiome. They are also present as rhizosphere microbiome. And these all microorganisms which are present in the soil, they interact with each other, they produce lot of organic acids, small molecules, hormones, and there is a lot of colonization and signaling that happens between these organisms. Now, this chemical crosstalk, or what we call as signaling, is something which actually enables the plant and the microorganism to work together. So it is very important that for having a sustainable agriculture scenario, we should have a proper rhizospheric management. And this rhizosphere management comes by utilizing these soil microorganisms. So the nutrient tapping ability, the water absorption ability, the different nutrient mineralization ability of these microorganisms have to be utilized. And when these are utilized, they are called as biofertilizers. Next slide, please. So let's understand the biofertilizer concept. So these are biological preparations of efficient microorganisms which improve soil and plant health. They increase the crop yield, they colonize with the plants, and it helps in the transplantation shock survivability, in reducing seed mortality, in shortening the flowering time. They also produce certain phytohormones which are helpful directly to the plant. So there are many components which have the biofertilizer segment, and they contribute and make the biofertilizer efficient. Next slide, please. So there are many types of biofertilizers. So if we go by organism, there are bacterial biofertilizers, there are fungal biofertilizers. And if we go by the functions, so either of the fungal or the bacterial, they will either be nitrogen fixers, they will be phosphorus mobilizers or phosphorus solubilizers, potassium mobilizers, they can be zinc solubilizers. So they can be organisms who are decomposers. So different organisms would have different role, and many such organisms, they have different categories in biofertilizers, either as bacterial biofertilizer or as fungal biofertilizers. Next slide, please. Now, the role of biofertilizer is in the rhizospheric management, which is the microbial management of the soil, which thereby increases the soil fertility and attains the sustainable agriculture goals. Now, if you see in this picture, we have different components where the biofertilizer helps. The biofertilizer helps in different stress tolerance in plant, whether it is a biotic stress tolerance. When I say biotic stress tolerance, it is the different organisms which are bad for the roots, which are pathogenic for the roots, which cause root rotting. So these microorganisms are actually kept away by the biofertilizer organisms which are inoculated, thus helping the plant to survive, thus helping the root to be healthy. Also, there are different microorganisms, as I just explained, which are present as bulk microbiome. Now, these bulk microbiome which are present also contains beneficial microorganisms. So the biofertilizer microorganisms that are inoculated, they actually recruit good bacteria or good fungus, and they work together in the rhizospheric environment to increase soil fertility and improvement in the plant. One of the other uses of biofertilizer is increase in water absorption, increase in the nutrient uptake. Now, this nutrient uptake, why I'm saying here is it relates to the starting slides of the presentation where I was talking about the nutrient use efficiency. Now, since the chemical fertilizer input that we are incorporating in the soil, your usage is 30 to 40%. So the rest, how will it get utilized? Now, these biofertilizers help in mineralization of these of these chemical input fertilizers which are there in the soil, and help in enhancing the movability of these chemical fertilizers into the plant. So they help in increasing the soil fertility by decreasing the chemical fertilizer input in the soil. Also helping in the different abiotic stresses. Now there can be drought situation, there can be a situation when the soil is alkaline, there can be a situation when the soil is incorporated with heavy metals. So these situations, all the stressed lands, or if it is a climatic condition, so the microorganisms in biofertilizers are capable in mitigating these stress factors and helping the plant to survive, to thrive in these stress conditions. So all this together, the plant health improves because the soil health is improving, the root health is improving, the plant health is improving, and the plant now becomes strong to survive the different attacks of the pest or insects. So that is also the defense mechanism also charges up, and thus you can see biofertilizer has so many roles in a plant development, which contributes to sustainable agriculture, because use of biofertilizer not only helping crop productivity, but it is also reducing the chemical input. It is also helping to enhance soil fertility. Next slide, please. Now, if we look about the biofertilizer market, so the biofertilizer market is increasingly, there is a surge in the demand for biofertilizer products now, since everybody is getting aware that the soil degradation is happening. We should have adoption of methods which will increase soil fertility, and one of the adoption methods is biofertilizer. So there is a lot of surge in this demand. There are many industrial players, there are government that is having different policies to incorporate this into the system. So because of this surge, it is estimated that in the year 2028 there would be an increase of 10.9% CAGR, which is a very important increase, and a jump, I would say, in the biofertilizer market segment. And if we also look on to in the globe, where is the most important market which is there? So if you see in the West, mostly in the North American side, you can see the market is very much established, and the Asia Pacific region, there is a lot of development in the biofertilizer segment. So taking the market into consideration, taking the benefits into consideration, the government as well as industry is putting a lot of effort and awareness for the general public to understand the use and the goal that it can achieve towards sustainability. Next slide, please. Now, one of the biofertilizer, that is a mycorrhiza biofertilizer. I would be just explaining this biofertilizer because our institution, the Energy and Resources Institute, TERI, it is known for mycorrhiza and the research that is going on from the past 25 years in this field in our institution. So this is a mycorrhizal biofertilizer where there is a fungus microorganism that is utilized for making this biofertilizer, and it's a beneficial fungus. What happens is that it associates with the plant, and the association is very, in a simpler language, if I tell you the association, so the plant asks the mycorrhiza to give it sugar, and the mycorrhiza says, the plant asks the mycorrhiza to give the nutrients, and the mycorrhiza says, please give me sugar. So this beneficial coordination is the mycorrhizal symbiosis, where both the partners are benefiting, and this mycorrhizal biofertilizer thus is a very important symbiotic fertilizer in the market. Next slide, please. Now let's understand how this mycorrhiza biofertilizer works. Now, if you see this plant, the area where the black lines are there, that is the root of the plant. So that is the rhizospheric region. Now, if a mycorrhiza association is there, you can see the red line. Now, these are very thin filaments of the mycorrhiza. When it associates with the plant, these thin filaments go deep down into the soil. and increase the area of the plant. So you can say that it is a mycorrhizosphere, the mycorrhizal rhizosphere. And in a simpler language, we can say that they are like extended arms of the root, which help in nutrient absorption, which help in water absorption in an enhanced rate. Next slide, please. Now, let's see what are the below and above ground benefits. Now, towards the left side, the picture, if you see, so there, the root area, it doesn't have a mycorrhizal association. The blue dots that you see and the other small dots that you see, that is water and the nutrients. You can see in the soil, there is a lot of nutrients and water deep down. But since the rhizosphere is concentrated towards just a small area, so the absorption is less in that plant. But if mycorrhizal association is there, the filaments of mycorrhiza, it captures a lot of area, it goes deep down, it encourages mycorrhiza encourages the plant to have lot of signaling that happens and lot of absorption of water, lot of absorption of nutrients. And there is also soil aggregation which happens when mycorrhizal biofertilizer is there. That is, it also helps in reducing soil erosion, which is one of the very important aspect in the present scenario. So there are certain chemicals that these mycorrhizal fertilizers secrete, and this binds the soil together with the roots, which help in decreasing the soil erosion. Next slide, please. So, in a total sum up, if we say mycorrhizal biofertilizer, it's not only important for agriculture, but for horticulture, for any stressed environment, which is either for heavy metals or highly alkaline, highly acidic, or it is a desertification, a land which is deserted. So, in all these areas, mycorrhizal biofertilizers are very beneficial. Along with that, mycorrhizal biofertilizer reduces the chemical fertilizer input by 25%, which is a very important scenario in case of the soil fertility, which the present public is concerned. Next slide, please. So, the sustainable agriculture, where we have the biofertilizer incorporated, it improves the beneficial microorganism presence in the soil, so that there can be a lot of mineralization of the chemical input that is present in the soil. It also helps in secretion of phytohormones, which are directly helpful for the plant growth. Along with this, it also helps in the nutrient use efficiency improvement, which actually reduces the environmental impact, improves the soil quality, and reduces the nutrient loss. Next slide, please. So to conclude, I would say the contribution of biofertilizer for sustainable agriculture production, there are various benefits. To sum up, there is economical benefit, that is, since the chemical input fertilizer is less, we will have reduced, the farmer will bear reduced input cost, and it will have higher nutrient efficiency. Since it will have higher nutrient efficiency, there is environmental protection because the soil structure and the soil fertility is improved. Since environmental protection is there, there is improved soil fertility, so the crop productivity increases, and thus there is food security in terms of not only the soil health but also disease resistance. In the last, the biofertilizers also help in reclaiming the wastelands. So the wastelands which are highly polluted, those lands can also be bioremediated by the use of biofertilizers. So I would conclude that we all need to be more aware of the biofertilizers, and the youth especially should come together. It can be biofertilizer entrepreneurship that the youth can open. There can be various research aspects that the youth can get involved in. They can also get involved in different policies, different regulations, framing with the government, and thus seeing all these benefits, the contribution that the biofertilizers give to the sustainable agriculture production, we should vouch, everyone should vouch for the use of biofertilizers. Thank you, everyone.
How can policymakers support the widespread adoption of climate-smart agricultural practices to achieve global sustainability goals?
Okay, so policymakers in with respect to, for example, if we take India into consideration. So there, one of the policymakers here is the Fertilizer Control Board. So they have now incorporated these biofertilizers in their fertilizer control board segment. So what they are doing is now modifying the existing policy which was not there. They are supporting the policies which will enable the environment towards climate smart agriculture, and they're also coordinating with the research organizations to help develop science which can help in agriculture, climate change, food security, land restoration. So all these aspects. So policymakers are very important to help to revolutionize the agriculture practices.
So next question is, what role do agroforestry systems play in enhancing climate resilience and sustainability in agriculture?
So, agroforestry, biofertilizers has a great role in agroforestry systems, both if we take into consideration all the woody plants coming up with the help of different biofertilizers, or remediation of the different deserted land. So, agroforestry system actually enhances the measures which are taken by the people to help in revolutionizing the agroforestry by using different biofertilizers. Yes, there is a very important role that the biofertilizers will play in this agroforestry system.
Okay, thank you so much, Ms. Leena.